Hello friends, this lesson is comparison of Otto and diesel cycle. It is a very important lesson both for engineering services as well as for gate examination. You will be asked so many questions from this particular topic, that is comparison of Otto and diesel cycle under the course Basics of IC Engine. This is presented by me Harshit Agarwal, graduated from NIT Nagpur in 2008. I have cleared Indian Engineering Services examination. I have got the offer letter from most of the Maharatna and Navratna companies. I have cleared gate examination as well. Regarding course fee, there is no course fee as such, but you can always contribute whatever you feel like. You can also follow me on the specified link. So to start with, comparison of Otto and diesel cycle. Case 1. This is same compression ratio and heat addition. I mean, in this you have to say which cycle has a more efficiency, if the condition given to you is that in both the cycle the compression ratio is same, as well as in both the cycle the heat addition is also same. Compression ratio is same and heat addition both are same. So which cycle will be having more efficiency, Otto cycle or diesel cycle? We will see this with TS diagram. We will draw both these cycles on TS diagram and we will see the comparison. Now 1, 2, 3, 4 is a simple Otto cycle. 1 to 2 is adiabatic compression. 2 to 3 is constant volume heat addition. 3 to 4 is reversible adiabatic expansion. 4 to 1 is constant volume heat rejection. 2 to 3 is heat addition constant volume. So 1, 2, 3, 4 is a Otto cycle. Now I have to draw diesel cycle keeping in mind the same compression ratio and heat addition. So 1 to 2 is the same compression ratio for diesel cycle. Now 2 to 3 dash is a heat addition at constant pressure. Why we have taken it till 2 to 3 dash? Why we have taken it till 3 dash? Because 2 to 3 is heat addition in Otto cycle and we have to keep the heat addition same because condition is like that. So we have extended this line till T3 dash because area under 2 to 3, this area should be equal to 2 to 3 dash because heat addition is same in both, right? And 4 to 1 is heat rejection and 4 dash to 1 is heat rejection in diesel cycle and 4 to 1 is heat rejection in Otto cycle. As you can see in this formula, heat addition is same in both the cycle, heat rejection is more in diesel cycle. So this term will increase in diesel cycle, hence its efficiency will decrease. So if you will get this condition in same compression ratio and heat addition which has a more efficiency, simply say Otto cycle has a more efficiency than diesel cycle because heat rejection is more in diesel cycle. So for the same compression ratio and heat addition, heat rejection is more in diesel cycle, hence its efficiency is less than Otto cycle. Next comparison, case 2 is if in exams you will be asked for the same compression ratio similarly and same heat rejection, same compression ratio and same heat rejection which has a higher efficiency. Now 1, 2, 3, 4 is a simple Otto cycle. As you can see, 1, 2, 3, 4 is a simple Otto cycle. Now we have to keep in mind for 4 to 1 heat rejection should be same. So 4 to 1 line would be same for both. 4 to 1 line would be same for both Otto as well as diesel cycle, right? And heat addition from 2 to 3 dash is in which cycle? Diesel cycle, because constant pressure is in diesel cycle and the slope of constant pressure line is less than the slope of constant volume line on TS diagram. So 2 to 3 is a constant volume line, 2 to 3 dash is a constant pressure line. So for the same compression ratio and heat rejection, heat supply is more in Otto cycle and hence its efficiency is more. I am repeating this again. 1 to 2 is compression ratio for both Otto as well as diesel. 2 to 3 is heat addition for Otto cycle. 2 to 3 dash is heat addition for diesel cycle. This is below 2 to 3 because this is at constant pressure, this is at constant volume. We can change this line, right? But we can't change 4 to 1 line because in question it is given heat rejection is same and heat rejection is same for both Otto as well as diesel cycle. So as you can see in this figure, more heat addition is in which cycle, Otto cycle or diesel cycle? More heat addition is in Otto cycle. So the efficiency of Otto cycle is 1 minus QR upon QS. Otto cycle has a more heat addition, therefore its efficiency is more. because denominator is increasing, its reciprocal will decrease, hence efficiency will increase. So Otto cycle has a more efficiency than diesel cycle for same compression ratio and heat rejection. Similarly, in case 1 as well, for same compression ratio and heat addition, Otto cycle has a more efficiency than diesel cycle. Next, case 3 is same maximum temperature and heat rejection. You just have to see which points are fixed. Same maximum temperature would be at 0.3, maximum temperature would be at 0.3, and heat rejection is from 4 to 1. So where we are starting is, we are starting simply from 1 2 3 4. 1 2 3 4 is a simple Otto cycle, 1 to 2 is compression, and 2 to 3 is heat addition, 3 is fixed point, and 4 to 1 is what, heat rejection, which is same in both Otto as well as diesel cycle. Now we have to draw diesel cycle, that is the dotted line. We have to draw diesel cycle, that is the dotted line. We will start from point 3 because we have to see the slope. Constant pressure has less slope as compared to constant volume. So 1 2 dash 3 4 is a diesel cycle, and 1 2 3 4 is a Otto cycle. So for same maximum temperature and heat rejection, heat supply is more in diesel cycle, and its efficiency is more. So in case 3, diesel cycle has a more efficiency than Otto cycle. In case 1 and 2, Otto cycle has a more efficiency in diesel cycle. There must be one question in your mind, that why constant pressure line is upper than constant volume in this figure, and why constant pressure line is lower than constant volume in this figure. Because in this figure we are starting from point 2 and we have to see the slope from point 2. That is why constant pressure line is below the constant volume line. But here we have to start with point 3 and we have to keep the slope less. If we will draw constant pressure line like this, so constant pressure line slope will be more, which is not correct, because on TS diagram constant pressure has less slope, so we will draw it upper than constant volume. That is why diesel cycle has more efficiency than Otto cycle in case 3, and in case 1 and 2, Otto cycle has more efficiency than diesel cycle. So I think this must be clear to all of you. If there are any doubts in this particular lesson, you can mark those doubts in the comment section and you can ask your queries as well, because these 3 cases are very important. Every year you can see in engineering services examination there is at least one objective question from this particular lesson, as well as in GATE. Right. Thanks a lot from my side. This is Harshit Agarwal.